So or change request to the agenda as it's shown there. So apparently not. Okay. So after bashing the agenda, Spencer and I am just shortly talking about the transport area directors and this non-com cycle. After this, we have a presentation by EMET about the MPEG media transport protocol. We have afterwards a small discussion about where we're actually trying to work on the evolution of transport. And then we have towards the end the enablers for transport layer protocol evolution of Sylvester, and hopefully enough time towards the end to have a bit of open mic discussion about evolution of transport protocols in the transport area. So before going ahead, we have so the news many people probably have seen is that I am not standing again for a third term, and my term ends in April next year at the IETF meeting in Buenos Aires. And so this is like a call for willing nominees for the transport area position. If you'd like to see more information, something like desired expertise, or in other words, a job description, you can go to the NomCom page. And I think on this page, you will see maybe in a month or so, I'm not sure, the official job description. But I think if you look back to the mailing list, did we post it there? One version?
Yes.
Yeah, we posted it. Oh, sorry, we posted the draft.
Comments.
The comments, right. You can see it on the transport area mailing list also.
Because we're transparent.
Yeah. So, in case we don't have enough nominees, read this and look at the picture. That's a nice guy called Golem, and he's waiting outside, I think, the banquet hall on the lower level. And you see, he has already a yellow dot, means he's part of the ISG.
Make good choices.
Yeah. And I think he has a simple rule. Everything he doesn't like, he just marches away. So, and over it. And he's big. And thanks from Spencer for making the slide and the picture. I would never seen this guy, so I'm too blind. Okay, then some heads up or clarifications. You like to say this one? So
we were going to do something in the middle, I thought.
Did we?
Check the agenda. The impact thing.
Oh, yeah. That's the signpost. Okay, okay. Yeah. Then we go. Sorry for the confusion, and then we can hand over to Emmet. Maybe do you want to use your own laptop for some presentation? I should have the right plug for you. Yeah, use this one. Yeah, we have been nice in queues, buffers, maybe buffer bloat. So that should work. So we can, but you have to go. Then, but you have to stand in the yellow box, in the pink box. Yeah, now we have to this one over there.
Okay. Yeah. Thank you. So this is a short presentation about the MPEG Media Transport Protocol, but I think what my purpose of being here is to initiate this discussion on the future of media distribution and get the IETF to be involved in this and get their valuable feedback. So next slide, please. So we, Martin. Thank you. So we are looking at an evolved landscape of media distribution. Our starting point in the MPEG was to address like broadcast use cases, but those have evolved so far that it's not the traditional broadcast that we are used to. The industry is also moving away from MPEG-2 transport system as the transport layer for media delivery. We're looking at an all IP network. We're looking at a variety or very rich media content that is being presented. So TV doesn't look the same way as it used to look. We are looking at like very high definition content with UHD, so with high dynamic range, very high frame rates, so very high bit rates. But we're also looking at very rich scenes where you have multiple video streams being displayed. We have companion devices that display parts of the service, additional content like news stickers and some additional descriptive content. We're looking at targeted advertisements. So it's quite different to what we were used to. And those were actually the drivers behind like the work in MPEG to phase out MPEG-2 and replace it by a more modern like transport layer. And this was done in MPEG as part of MPEG-H. It's published standard 2308 part 1, and it provides like the system layer for the MPEG media. So MMT defines a transport protocol, and that's what I'll be talking about here. It has also like a signaling layer, FEC framework, but also like looks into presentation layer as well. So looking at HTML5 and enabling scene updates in broadcast environments, for instance. So next slide, please. So the requirements we had, so we needed like something that is generic. So it should be like similar to MPEG-2 so it should work with any media type, especially, I mean, the MPEG media types, but it's not limited to that. And it should support both real-time and non-real-time media distribution. It should support multiplexing, so easy multiplexing is a requirement there. So MPEG-2 was quite hard to remultiplex. So if you added like new components to the stream, if you want to do like targeted ads, so replacing portions of the content with content that is coming off the broadband channel. So it needs to be like easy to multiplex. It has to be self-contained, so like MPEG-2 is self-descriptive. So once you get access to the stream, you'll find there signaling information that describe all the components that exist there. Maybe also like neighbor services and so on. So that's why we had to define this signaling layer as part of of MMT. So focus of the transport layer should be on the delivery. So we decouple presentation layer from transport layer and support for multiple sources. So I said content might be coming from different sources and needs to be remultiplexed at the receiver side and resynchronized also at the receiver side for playback and also for playback on different devices, for instance, in the home environment. So next, So why we did not opt for RTP at that time? So lack of multiplexing. So we believe that multiplexing in RTP is quite limited. So right now I think only support for RTP or TCP multiplexing, but not multiple service components. Server maintenance, so we wanted like something that supports generic format instead of having to develop like a special payload format and having to update your streaming servers each time you have to add support for new codecs. We didn't appreciate the coupling of presentation and delivery for different reasons. So having like RTP timestamps or presentation timestamps in the protocol is not flexible enough. So when we think about redistribution of content, when we think about consuming content coming from different sources, and when we think also about like rich presentations where you have like targeted advertisements or content that replaces other content in the presentation based on some customized or some user profiles and things like that. So we thought it's very important to separate and decouple like the presentation layer from the delivery layer. Also, the limited support for non-real time. So I said the scenes are quite rich, so we might want to present images or companion content at the same time as you're presenting the audio video. And that might also go to other devices in the home network, for instance. So we had, or this transport protocol had to provide support for that. Next. So this is like an architecture that we use. So we have like content providers, which could be like multiple sources. We have a sending entity, so that's the server, and the receiving entity. And I said there is some signaling in both directions. So receiver would report back about the reception conditions to the server, and that can be controlled, like so how much reporting is required by the server, and the media delivery goes from the server to the receivers. Next. So the protocol itself is like a basic protocol that we are looking at. So it's we thought, I mean, we like the idea of LCT, for instance, as a building block. It lacked a few features and had like some features that we didn't see a need for. So the starting point was something like LCT. But of course, our target was to optimize for media streaming, so very or low delay support for low delay. The protocol itself is quite simple, so it has like a type field which would identify the type of the payload, and we define a limited set of payloads, so four payload types. Then an identifier for subflows. So that's a feature that we don't actually have in LCT, but we need here. So we have to support like multiple subflows or substreams that correspond, for instance, to the different service components, audio, video, subtitling, or static content, and so on. We have a timestamp, which is like a delivery timestamp. It's something that, for instance, LCT has an optional header field. RTP has a presentation timestamp there, but we opted for a delivery timestamp. So that would enable, like for instance, measuring like delay, jitter, and so on. We have a sequence counter, a packet sequence number, which is like scoped by the packet ID. So if there are losses in a particular service component, those can be detected through the packet sequence number. And we have an optional packet counter, which is like a global packet number for the whole MMTP flow. And it's optional. because it makes like remultiplexing quite difficult. So if you wanted to multiplex without the packet counter, you don't need to rewrite any of the packet headers here. If you had the packet counter, then you need to resequence the flow. We have header extensions and an optional FEC payload identifier at the end of the packet. So that's pretty much what the packet header contains. Next slide is about the procedures. So we define like a session which consists of exactly one MMTP flow. An MMTP flow is identified by the destination IP address and port number. So it can support like source specific and multicast and any source multicast. In particular, we are interested in the case where receiver gets content from different sources at the same time. So it consists, an MMTP flow consists of multiple subflows. Each has its own packet ID as an identifier. And each subflow would carry like service components, which could be audio, video, subtitling, signaling, generic data like regular files and so on. And it supports FEC at the flow or subflow levels, so you could decide to protect the whole flow or only like the most important parts of it, like audio, for instance. Or you could have like multiple FEC protection where you use different code rates for the different service components. Next. Payload formats, I think it's not relevant for the draft that we have here, but I think it's like one of the core ideas there is to support a very limited set of payloads which are generic enough to address all needs that we foresee. So we start with the with support of a container format, so payload format for the MP4 files. So the idea is that whatever you can put in an MP4 file, you can stream using MMTP. We support the payload format for generic data, so that's similar to what you could do, for instance, with ALC and Flute and FCAST. So similarity to FCAST is that those files can be self-contained, so they have their own metadata as part of the transport object. And we support like signaling. We have a payload format for signaling information, which could be XML or binary representations of signaling messages. The last payload format is for repair data. So we decouple like repair data from the actual source packets by having them on their separate on a separate payload format. And fragmentation aggregation are performed at the payload format, so we don't support that at the protocol layer itself. Next. I think I won't waste like much time on the discussion of the payload formats, but the idea that if you support like streaming of a particular container, I've seen, for instance, here in the IETF talk about defining Matroska as a container format in IETF. So that could be like an additional payload format that we can adopt there. And whatever you can store in Matroska with an optimized payload format for streaming like Matroska files, we could address the needs of certain applications. So far, the only format we are supporting when it comes to media streaming is the MP4 file format. I said that that's the decision done in MPEG, and the priority was given to the MPEG media formats. Next talks about generic file delivery, which is like a mode that allows the application to send any type of file. Self-contained, so it provides in the payload data, it will carry the metadata of the file, and the delivery is like based on the offset of the payload into that file. So we have a transport object identifier similar to LCT, for instance, and an offset which places the payload inside that transport object. The difference here is we're not using like an identifier or a sequence number. We're using the offset. So that's more flexible when it comes to locating or handling the packetization of the file. Next is about the signaling messages. So we have like a generic format for signaling messages, both in XML and binary format representations. And the message payload can, it's flexible, so we can assign like a message ID for that message and define like the message contents. So we can define like new message content there. So it's in a way very similar or borrows like concepts from MPEG-2 signaling. And the last one is the FEC framework. Oh, maybe I don't have the FEC framework. So we have a built-in buffer model, so a hypothetical receiver buffer model, which we can use to like at the receiver side to at the sender side to make sure that given like some restrictions on the receiver side, restrictions on buffer capacity and on end-to-end delay, that we can ensure like correct reception at the receiver, so no buffer overflows or underflows. And those, the end-to-end delay that these signal there is meant to cover like jittering, for instance, if you follow like different path, transmission of a different path. It covers also like FEC decoding, reordering, and so on. So that's pretty much all I had to say, I think, to this. We are here to talk about congestion. So IETF, I think, has more expertise on this topic. So far, I said we designed for provisioned networks or broadcast networks, but we'd like to address like hybrid use cases, which are like very crucial for next generation media. So we assume that people will be consuming content both over broadcast and broadband simultaneously, and we need like congestion control for at least for the internet part of it. So we think that maybe we can reuse like existing components here, for instance, broadcast like WebRC and TFNCC, things that were done in RMT, but also over broadband, so the regular internet, maybe the work that is done in RMCAT and so on might be relevant to enable like MMTP streaming over the internet. But also, I mean, for next slide, please. So we are also looking at ways of developing like this all IP media delivery, so that other like SDOs like MPEG, ATSC, 3GPP, DVB, and so on find something that is suitable for them. So we are, as I said, we are looking also at like the developments in the media streaming of the internet. So where Dash, for instance, or streaming over HTTP is playing a role, but also looking at improving that. So by looking at different like transport protocols that might reduce the delay, the streaming delay, the tune-in time and channel switch time and so on. And for that, we believe that having like a development of a suitable protocol here might be quite beneficial for the industry. So we'd like to hear, I mean, the opinions of the people here in the IETF. We thought that this is very similar to what RMT has done, but also enhances that with the like new use cases, namely streaming use cases, hybrid delivery, and so on. So this could be maybe potentially done in by reviving RMT and working there on this. We could start maybe new ad hoc group or buff maybe and look at the use cases that we are considering. And the last option could be like that we pursue like an informational RFC track. So we're open. We're also open to giving control to the IETF about this protocol or the development of this protocol, and sync up basically with what the IETF does in our future releases of the MMTP protocol in MPEG. So that's all I had to say about this. And
okay, thank you. We have a bit of time for questions from the community.
Matt Mathis, one of the things I didn't hear you say was anything about what you envision sort of the outer layer being. Are you imagine yourself over UDP or
yes,
or directly on IP here?
Yeah. So at least the initial consideration is that UDP would be the suitable protocol, but we've seen also like thoughts and contributions towards like doing MMTP over WebSockets or delivering like MMTP content over WebSockets for better integration, for instance, with CDN. So TCP could also be like another alternative. Yeah, but UDP is the main.
So one of the problems that you have here is embedded in this are some sort of unsolved problems that have been hard problems that have been unsolved for a long time. And these problems are replicated. So one of them is sort of the version of how do you deal with specifying congestion control for something that looks like a tunnel when you don't know anything about what you're carrying. And there's sort of a recursive congestion control problem there.
So sorry, it's hard to understand you. How do we deal with what? Can you repeat?
A protocol that looks like a tunnel, which
yes,
can't own responsibility for when data arrives, but is sort of responsible for congestion control in some sense to the layers, other people who are sharing its channel. This is a hard problem that has not been solved. Part of it is, I think, because we're actually asking the wrong question, and I don't know what the right question is. Still don't know what the answer is, and I don't think this work is the right place to solve that question. But this work would be a lot easier if that question was answered.
Yeah, I'm not sure I agree there, because I believe we control what is delivered there through defining a very limited set of payload types. So far we have only 4 payload types which we support, so we know quite well what we are delivering. So in a sense, I slightly disagree.
So we just close the line so people at the mic can just work through, but nobody else, please. Lara's not just in time.
Mia Kulevin, I don't want to be word picking, but you said like in a talk group, so this seems like a pretty big effort. Don't think there's anything we can do ad hoc here because we do this for a long time already. And the interesting part you said also for me was that you said you have additional requirements for RTP, and RTP can't solve what you need. So maybe it would be an easier solution to actually figure out how we can change RTP to make it fit to your use cases. Because I think there are a lot of things you can reuse basically, or which already fulfill what you need, and maybe there's not much to add. I don't know. I mean, it was a very short presentation for this whole big thing, but that's something to think about.
Yes. Yeah, I think we thought about that actually. So we thought about, for instance, defining a payload format for delivering ISO BMFF or MP4 files as a container. Of course, that effort has been done, for instance, with the MPEG-2 transport stream over RTP, which was at least reading the RFC itself, saying that it's a bad design, like overwriting, for instance, the RTP synchronization procedures with MPEG-2 synchronization procedures. So I think there are like fundamental like differences which led us to like the decision of going like more towards something that is different than RTP. But of course we are here, I mean, to raise this type of questions and see if we can do something about that. reusing RTP or maybe reusing components that RMT has defined, like HCT, AHC, and so on. So we are open to this.
So, Gori Fairhurst, I'm pleased you've come here. If you're going to be delivering 30 megabit or so bit streams into my house and over my wires, I would love to know that they were somehow doing the right thing. So thank you for coming here. Is there a chance to change your specs as you evolve? I mean, or are you asking just to standardize what you already have?
I think we are, so this could be like starting point. What we have done there could be just starting point. We are open to changing that, to evolving that.
Okay.
Either way the group sees here. Yes, so 30 megabits per second, I think I'm not like exaggerating. I think we're looking at a 4K streaming already started in the US like a while ago. UHD streaming. We're looking at bit rates that are like really around 30, 40 megabits per second. And that being delivered over like best effort internet. Of course, I mean, the content providers would usually have some agreements with ISPs, but nevertheless, I think it's, if it's done wrong, it could result in disastrous impact on the internet.
Lars, I guess I'm a bit worried because your starting point looks an awful lot like a finished system design. And so in the beginning you said, and Mirja said that earlier, that RTP doesn't work for you, but I don't understand why. And without understanding what your motivations are for doing something very different, it's going to be hard for us to understand how we can help you. As an individual, I would think the chances are slim that what you have here will be what comes out of an IETF effort if one were to be started. And there might be quite a bit of dissecting and refactoring going on if we do something here. But I think that understanding what the issues are with RTP, which we are very biased towards RTP, obviously, because it's our baby and we think it can do anything, would be I think a good starting point, right? To see really what does it not do for you, right? And a lot of things you have on here, I think we have solutions for that could work in an RTP-based architecture. But if there's some fundamental thing that is not working, and that's why you need all these other things, that will be, I think, a good starting point. And I think maybe the next time you come, which is, as Corey said, it's great that you're here, and I hope you come back. I would really like to know that part. So start in the beginning. I don't need to see packets, header formats in this presentation. I would have liked to see RTP doesn't work for us because we want to do this and it's inefficient or it just can't do it for these reasons.
I agree. I mean, I tried to touch on that here, I think, in a few slides. Earlier, maybe I didn't take enough time to talk about that. But I agree we need to look at case by case, point by point, and see, can we do that? So can we do a self-contained?
Can you give me one big reason that is very simple for me to understand, because I'm not a media expert.
Yeah. So in the sake of time, I would propose to take this offline or maybe on the list so that we can continue. So
if you had to pick one thing, what would you pick in one sentence?
One thing I would pick self-contained multiplexed stream that carries all components of one media session. I'm not sure you can do that with RTP.
Yeah. So, okay, I would say, so we're running a bit out of time. I think there's interest, and I think it's probably wise to continue this on the area list, or I think you're talking anyway with Gori, and maybe Gori, you and me manage to meet tomorrow also for some minutes to figure out what's going on there. Okay.
Thank you
very much. So I think I'll hand over to Spencer, who explains signposts, isn't it? Let's see if I can.
Yes, now we do signposts. So, We've had a lot of conversations, probably starting about TAPS BOF era, probably a little over a year ago, with the evolution of transport and things like that. And this has gotten a lot of stuff going on, and we just wanted to help people figure out where to participate in this. So this would be a mea culpa, which means through my own fault, but I had help. Lots of help. So, like I said, we've been pushing very hard on protocol evolution in the IETF, and the IEB, and now in the IRTF. And we want to involve people who need to be involved, and we haven't really made it clear how to be involved. This is the part where I'm falling on my own sword, and there'll be plenty of swords sticking out the back for other folks. So here's where to go. We're doing transport services in the TAPS working group. That's an active open mailing list that you all may very well know about. Aaron Falk has been doing work on how ossified is the protocol stack, or hops, and trying to do the kind of measures of ossification and what protocols, what the roadblocks in existing network paths look like. So that's the mailing list for that. There's a new one that's sponsored by the IAB, which is a open discussion list for IP stack evolution. It's associated with the IP stack evolution IAB program. You all would have seen the SPUD mailing list, which was used for discussion of the SPUDs BOF in Dallas and things like that. So kind of, anything that's follow on to that. And then TSV area for general evolution discussions, and probably appropriate for discussion of the presentation that we're about to have. You guys may see references to a Stack Evo at IAB.org, which is the private program mailing list for Stack Evolution. You may see references to the semi-workshop IAB mailing list. That's dormant for now. If they ever do another workshop, it would pop back up. Some of you may have seen references to something called IETF93-TSVAREA, which was kind of how very early in the conversation that turned into the IP Stack Evolution IAB program. And it's obsolete, and we're going to go ahead and close that.
Can you explain UDP35 and SEMI?
I'm sorry?
What are the references of those words? What are the expansions of SEMI?
Over here? No. Oh. Yeah, we're just a little rumbling here. Sorry.
Yeah, we can listen. What was the question?
I can answer the question.
Okay, good. Okay. Go ahead.
Hi, Brian Trammell, IAB. Semi was Stack Evolution in a Middle Box Internet. That was a workshop that was held in Zurich, January of this year. That was basically the workshop discussion list for workshop attendees. And then UDP35 stood for UDP as layer 3.5 of the Internet protocol stack, which was, we had no idea what we were doing at the time, and we're like, we'd like to move forward, and we are not sure what, but we have this kind of suspicion that UDP might be part of the answer, so that was the thing that stuck to it. And then, basically the only discussion on that list was more or less, okay, this list name is terrible. No, I mean, referring to it as we're going to fix the internet with UDP is kind of terrible. We need to think about this a little bit more, which is why. Yeah, we were naming it by what we thought the solution might be, at the end of the day, which is an excellent way to do unintentional engineering. So I hope that answered the question. I would like to say this is the public announcement of the fact that there is a Stack Evo Discuss at IAB.org list.
And I will send a note to that about that to the TSV area mailing list as soon as we have anything that looks like a network.
I've got network. I can send that right now, actually, if that's cool. Yeah, I'll do that.
Thank you.
Can you progress this for a while? Because I don't know.
Okay, can you hear me? Okay, I'm here to present our ideas, enablers for transport layer protocol evolution. We really try to follow all things happening in transport layer protocol evolution. And on the next slide, there is some background information on how we perceive that. Please go to that next slide. So we have seen experimentation with transports using user space implementation. That is really good because there is an app speed evolution compared to standardization or being in just the browsers. I mean, some of these are in the browsers, but so it's much faster. There's fast deployment, but less standardization. That is happening mainly over UDP. For example, quick, but also if spot whatever that will be happens, that will enable similar things to happen. We've also seen that middle box issues are being addressed. So middle boxes assume a given TCP wire formats, and that is really putting that is really ossifying the network. But end-to-end encryption and some applications like gaming really provide the hope, and that is enforcing to let UDP pass, also to let probably encrypted UDP pass. So there are some efforts here, top, spot, the stack evolution problem, TCP maintenance is evolution as well, also quick is happening. So this is some kind of background, and what is the scope of this presentation? That's the next slide. Please go to that, please. So based on that, we put requirements on a TPA framework to achieve a healthy ecosystem and also to keep up the pace of like fast evolution. We wanted to also investigate what is the effect of an accelerated TP evolution. What happens if many app developers start developing their own TPs? What can we do to still keep things going? Also, how is it stable to keep the stability of the internet in this case? So we have these requirements, and we have some ideas. We have some ideas in draft, and also I modified some of these ideas. This draft was originally submitted to the spring IETF. But what is definitely not in scope is expected features of transport protocols. So this is about the framework. Yeah, please. So we group requirements. There are some control requirements, and this might sound strange. So we say that we should be able to enforce expected TP behavior. Implementations might be buggy or malicious on purpose. For example, congestion control might be too aggressive. I mean, today it's not happening. We are having extremely friendly implementations in most of the cases. But if you allow any application to have a transport protocol, it can easily happen by mistake or on purpose. And we would like to protect other flows of the same user. We would also like to protect the user in a sense to not to not send too much data by an application which he wouldn't like to send too much data. We would like to protect other users sharing some kind of resource with this flow. And we would like to have some behaviors to be enforced. For example, congestion control, aggressiveness, or a given congestion control, MTU, packet pacing, whatever else we can imagine as something to be enforced. Also, we would like an option to allow the path influencing transport protocol selection. Why is that? Because the path might offer enhancement. It might offer some cooperation with some transport protocols, or that is the opposite of cooperation. It might be blocking some transport protocols on purpose. And if we select such a protocol, then it will not go through the path. We would also like to ensure that the user or operating system has control over things. For example, what transport protocol is selected for a given application, or what is the preferred resource sharing between applications of this user, of this OS, and application streams. And also, if there is any communication from middle boxes, especially on behalf of the user, then the user would probably like to have the final word in that. So even if the application is saying something and the user would like to have something different, he might want to change what the application is saying. So please go to the next slide. Also, there are requirements for accessibility. So applications should be able to access available transport protocols. So any transport protocol, or at least any general purpose transport protocol, shall be possible to select by applications, and it shall be possible to be inserted to a transport protocol selection framework. I've listened to the quick Bob of yesterday, and And that was the time I realized that Quick is only implemented for Google Chrome, and it's if I understand it right, it's not implemented for the Google's YouTube app. And if there is general purpose transport protocol, it would be very nice if that could be somehow inserted into the system, even if that is not in kernel, and be accessed by other applications. And also part of the accessibility, as there will be more and more transport protocols, it will be harder and harder to have consistent transport protocol selection, which means selecting cooperating transport protocol instances on both end host and in any middle box involved in transport protocol layer. It might be, in a way, in some cases it's really simple. When you develop both the application and the server, you can develop your own method. But if you look for web, and if you imagine more than one or more than a few transport protocols for web, it becomes much more complex. So please go to the next slide. We do believe in privacy and security, and these are really, really, really important requirements. It's important to ensure confidentiality of end-to-end communications. We think that in some cases it may be justified that a middle box accesses and modifies the transport protocol headers or the transport protocol itself, but in that case, the end-to-end content should be protected somehow differently. And also, we would like to ensure security of end-to-end communications, also to take reasonable effort to avoid that any third parties could exploit implementation of flows in transport protocols. So, for example, encrypting or authenticating transport protocol fields, including user space transport protocol, can help there, because that's if you make the encryption authentication part stable enough, and you test the end-to-end implementation, then it at least has to be the end host inserting something nasty, and man in the middle cannot insert anything because that is not authenticated and can be discarded by the authentication layer. So you don't have to be that prepared for testing. It's not saying you shouldn't test your transport protocol. It's just saying that you should have minimal attack surface on a not too tested transport protocol. Please go to the next slide. And we believe that there is a huge amount of value to allow the access provider to be part of the value chain when that is accepted by one of the endpoints. And we see two levels here. One level is selection between different trade-offs in local domain, quality of service, policing, which is most fit for the transport protocol and or the application. So there are examples here, selecting between lower latency and higher utilization, selecting between higher throughput versus more stable throughput. It doesn't normally mean that the amount of resources allocated to that given flow changes. It just means selecting different amount of resources. Brian, would you like to?
Just get my place in line.
Okay. But we believe in a higher layer of cooperation when the quality of experience can be improved further by increasing the resource share of critical applications, which we believe may be made fair in the longer run, though that needs incentives and further consequences. And we actually wrote a draft about such examples. Any of these shall be explicit, cooperative, and extensible, which improve performance, but which, again, might have consequences. For example, economic consequences, but other consequences to not misuse, especially the increasing resource part. And we believe that it shall be possible for the end host to opt out and get reasonable default handling. Which means, at the same time, that any middle box has to provide demonstrated value accepted by the users to actually do something. Also, we believe that different levels of trust shall be possible, and which means different solutions, from basically encrypting everything over UDP, hiding everything, accepting this default treatment, to even accessing content if there is enough trust between the endpoints and the middle box. Please go to the next slide. And any of these requirements shouldn't result in significant degradation of performance characteristics. When achieving the requirements, I mean low setup latency, reasonable throughput, especially in long signaling conversations shall be avoided, especially those which delay packets. This is valid for the common case. We imagine some exceptional cases, for example, when a transport protocol to be used can be downloaded to whatever system can store a transport protocol, and then use the transport protocol. But this is really an exception, not the rule. Please go to the next slide. So we have some ideas. I think that we believe some of our ideas are covered quite well by our understanding of the SPLAD initiative. So that provides an in-band channel, a protocol for middle box communication. There is an explicit communication and behavior there, and that provides the potentially authenticated and/or encrypted messages to the middle boxes. I mean, SPOD might allow a separate signaling channel. It might be within SPOD. It doesn't really matter from this perspective. But this encryption to the middle boxes shall be different from the end-to-end encryption. And we believe that is a very important piece of the puzzle to achieve a healthy ecosystem. And I think the discussions in SPOD are very interesting to us in general. So the details are not about SPOD in this slide set, but please go to the next slide. Rather about trust and enforcement issues. And that is where we think that within the device, the end user should control resource sharing and congestion control aggressiveness, which might, for example, require that congestion detection is visible for control functions. So that means that congestion should be possible to detect outside of the application, somewhere below the application. For example, if the transport protocol is implemented in the applications. It might require policing solutions in the end host. We might want to communicate the congestion control flavor used to, for example, middle boxes. And also, we believe that the end user should have the final word in what is communicated to middle boxes with what authentication keys he might have. And also there is some trust issues between end host and middle boxes. So what keys can be used for a given communication? How can we get the right keys into the middle boxes to have an encrypted communication, but at the same time to be able to have meaningful discussion with the middle box? Also, who can decode different parts of the communication, metadata, content, transport header, and what is the possible consequence of the middle box communication? How that can be communicated back is also an interesting question, and I think partly a trust question. So please go to next slide again. So again, how should control these? Should it be the operating system? Should it be some part of the operating system like application store? Should or could it be sometimes the network vendor? Should it be the user? Should it be something like a community database on behalf of the user, similarly to, for example, adblock plus filter rules? All of these have reasons to control, and there are some examples in the following slides for this control. Please go to the next slide. So there's an example here. This API looks very similar to the TAP API going down to something we call the trust and policy controller. And in this architecture, we believe that the trust and policy controller may receive rich metadata because that is controlled by the user and the OS. And that controller might, in a way, translate this metadata to something like treatment and network information. And at the same time, that should include removing privacy-sensitive part. And it could determine preferred treatment and other metadata to communicate through something we call middle box cooperation protocol, using a database and using user configuration. And he may also influence transport protocol selection. And in a way, a beauty I see in this concept is that the same application, same operating system, same database, but a user with different preferences might result in different treatment and network information communication to the middle boxes. But at the same time, for the user, it's not intrusive. So it's not, this decision is not made when he is using applications. The decision is made when he is configuring this trust and policy controller, if he wants to do that. there should be meaningful defaults there. But I mean, as an example, I could choose the reasonable database and the reasonable setting for my parents, for example, who are completely unaware of any kind of technology here. So please go to next slide. This is a different example. I put some random boxes here. Trust and policy controller is included here. There is something called protocol selection, protocol parameter setting, policy and quality of experience selection. Some API similar to TOPS. Some API is different because the transport protocol is included in applications. There are many things here like joint bottleneck detection, policing, something like SPOD or middle box cooperation protocol. Different middle box signaling which determines what to have. We have transport protocols there. And there are some different levels of trust. So we do trust some of this code, but we don't trust or trust other codes less. And there is an example here. So if you look at this application, having a transport protocol inside, if you go to next slide, I made that application red, which means that this application is doing somewhat unexpected. And that can easily happen when the transport protocol is within. And then one solution is to remove that application. But maybe that application user and something can be done, but it takes the time for the application developer to change his application. So what we can do is on next slide is to change the rules in this trust and policy controller and apply an app policing solution for that given application in this case, and to propagate these settings to the databases soon enough. And you don't have to act on the application immediately in that case, and you don't have to disable the application immediately in that case either, which can be an interesting consequence of solving some trust issues here. But these are both of these examples, this one and the previous one, are in a way wide examples, not meant to be like final solutions or recommendations in any way, but to illustrate what can happen if we think about these trust issues. Please go to next slide. Okay, so this is a summary about trust. So we believe trust has to be handled within the device. User should have control in the end, but that control should be almost invisible during using the applications. Sometimes even always when the user can accept meaningful defaults there. And we propose a trust and policy controller function which can do all this on behalf of the end user, and actually databases of OS vendors and network vendors might be included there. Okay, next slide, please. So in summary, we put requirements on a transport protocol framework to achieve a healthy ecosystem, fast evolution. We propose solutions, or rather we propose ideas to meet these requirements. We think SPOD is really important there. We also think that trust and enforcement issues have to be handled, and we presented some ideas for this. And then there are several open questions, especially in the area of trust and enforcement. What is the task of IETF there? Here, what is next? What is missing? Is it IETF thing at all? Do the potential gains with this justify this kind of complexity, or can we have something similar, simpler, and good enough? And I think that was my last slide.
Brian Trammell. I've been up here for a while. I'd like to go back to actually, no, that's a really tiny nit. Thank you for putting together a consistent set of requirements and asks for how this would work. My first question would be, there seems to be a little bit of a preoccupation maybe in this design with not trusting the transport protocol. And I wonder if you could say anything about that and why that seems to be a first-order design principle of this system.
Mm-hmm. Because we believe that fast evolution means much more freedom, and if there is that much more freedom, app speed development, some application developers will have these not so friendly transport protocols by accident or by design.
And by friendly you mean from a TCP fairness congestion control?
Yeah.
Okay.
And I think we actually should allow. I mean, if you take our transport protocols, IETF transport protocols, I think these should be trusted by default because we know that they are behaving nice. Well,
I mean, you know that the RFC says that they should.
Yeah.
I mean, I can implement TCP on top of SPUD.
Yeah, you can.
I can do it in like a couple of hours, but I wouldn't want you to trust it because I want it to go fast. So I'd probably set the initial window to something like 4,000.
Yeah, but
I don't think you want to trust any TCP I can write in a couple of hours. But that's the point that I'm making.
That's why I said by default, if you by any means realize that this flavor of TCP has this problem, you might want to change your database and apply some kind of policing which you trust.
Okay. And people in line behind me, feel free to throw me out of line because this is going to take a while. Let's go backward. Show me the big color for architecture slide, please. This one, yes. Yeah, this secure. So, well, the thing that's here that isn't like, so you have a set of requirements. You're basically pointing to a bunch of other work going on in the IETF, and thank you for at least. I read the draft, and it is a coherent vision of the future. I won't say anything more about it. This seems hard and dystopian.
Why dystopian?
Exactly the network we don't want.
This, yeah. And I don't want to say anything unnice about other standards organizations, so I won't. I'll focus on the hardness in that the trust and policy controller is now the attack target and the attack service. This is basically the place that if I want to own the internet, I will own that. In order to make it work at all, you need to solve the key distribution problem. And if you're going to solve the key distribution problem, you can apply that solution to better things. Can you go back to like slide 6? I think it was slide 6.
6? Ooh.
Yeah, no, 7. 2.6. The thing that scares the hell out of me here is the statement, it shall be possible for the end hosts to opt out of middle box cooperation.
Or not opt in, yeah. Is it because it's
there's a giant difference between those two things, and I think that kind of exposes the vision behind the vision here. That whole bit makes me a little bit angry, actually. That the idea that, okay, well, we're going to build something in the middle of the stack that's going to handle all of the trust and distribution, which fortunately it won't work, so that's good. At least we won't be able to build that part. And then we're going to make it transparent to the user so they don't see what's going on. And maybe if the application developer is nice to them, and maybe if they know enough, maybe we'll let them click the box that turns off the value add. Mm-hmm. And I don't think that's the internet.
No.
I mean, I don't know. I hope it isn't.
I mean, that's definitely not the purpose with this one. The purpose is to allow this, and I think opting in is a better. I think actually, from what you say, I should have definitely written, it should be possible for the end host to opt in.
Yes, at a very minimum.
And if the middle box cannot provide any demonstrated value, then he will not opt in.
At a very minimum. I'm gonna go get back in line after. I'm gonna like Christy.
There is, when I understand that.
Please state your name.
Christian Rittemer, Microsoft. There are many requirements expressed here, and what you present here is also what was presented as the motivation for SPUD and other things like that. And basically, I have a hard time believing that it is either in good faith or good for the internet or whatever. But there is a real problem. The real problem is that if we want evolution possible, we want to be able to not trust the end-to-end transport. I mean, there is no reason that the network shall trust the end-to-end transport. And it is true that the current situation in which we believe that the end-to-end transport has to behave in a certain way, otherwise the whole internet will collapse, that's actually very fragile. So what we should study is what is the proper way of, in the network, ensuring that the network is stable, even if the end-to-end transport is not necessarily trusted to do all that kind of stuff. And there are solutions in the range of active queue management, traffic profiling, etc., that make sense. And you can do active queue that you make sure that each of your users are the same, by and large, cannot step on the other user's foot. If you do that, then it doesn't matter what particular transport a user uses, because they cannot hurt the other guys. And I think that if we take that in those terms, as in, I manage my network to make sure that even if someone misbehaves, it only affects himself and not the other guys, then we have a much more decoupled interface. We don't have to go spy into exactly what the other guy is doing. We can have a generic contract. And having a generic contract like that is probably much easier to have than trying to go look at exactly what is implemented in each box.
I think the thing you are saying, or as I understand it, is assuming that we want to have this kind of like always fair share for everyone. And
well,
I think
no. That's an easy to understand example of one possible policy. You might have a policy that says, I mean, if you pay 10 times more, you should have a bigger share, whatever.
Okay,
that's not the
but
problem.
okay, share independently of the content and the importance of the content and the state of the application.
Absolutely. Because if I pay for my network, who are you to say that this stream of music is more important than my gameplay?
I mean, I think that's why it's really important to be able to switch this whole thing up. I do believe that there are cases when the resources are really scarce and when you can have much better overall quality of experience out from your network if you allow that kind of differentiation. And if you don't accept that, it's really fine.
No, I truly do not. I truly do not. In particular, I do not believe that there is a trade-off between latency and bandwidth, or between reliability and bandwidth. Because those kind of things can, if they are real, they can be dealt with end-to-end with proper application of forward or correction or whatever. I mean, you can do that.
I think there are end-to-end solutions. I think solutions at the bottleneck can be more effective. Also, end-to-end solutions can, I mean, like, just take an example. If you take fair queuing and you take LEDBET, then fair queuing most likely destroys the LEDBET behavior.
Look, I mean, I don't want to debate the details on how to implement queue management. What I'm saying is that...
Please use the mic.
Okay. What I'm saying is that expressing the problem in the specific term of how to prevent congestion of the network is much more likely to get us a good architecture than having an abstract discussion about the abstract possibility of abstract middle boxes.
Yeah, it's, I mean, then in a way, point taken. We can have examples of like concrete solutions where this can be useful. And we are happy to accept comments there why it can be done without communication.
春生雄鹏华为 Presently, I like this PowerPoint to provide a seasonal thinking of the transport service, but I still have some concerns on some technical issues. For example, the middle box. We all know that during the path there's a multiple cascades middle box. You're talking about the middle box coverage. My question is, there are multiple middle boxes in cascade. How to, from the sender or the receiver, talking or covering from the middle, not just next hop middle box.
Yeah, that's far from being trivial. I think that there is a simple case when there are two access providers. There are basically middle boxes of these two access providers, and when it comes to the transit in between, it's the task of the access provider's network to find something right for this kind of traffic. But I do understand that there is this complexity of several middle boxes, and I don't have the answer for that.
Lars Eckert, so when you have a network that has resource constraints, right? You can either spend money on doing something like this, or you can spend money on putting in more capacity.
Yeah.
Why would we do this instead of putting in more capacity?
Because
cheaper. Come on.
Because hopefully it costs less, or there is a point till you can put more capacity.
Even if you could put in a little bit more capacity, so this stuff will never get you more. Right? This is all about policing and regulating and making, scheduling. Just put in more capacity. Right? Building an architecture around administrating scarcity is not a good idea.
Yeah, I mean, if the cost of additional capacity is reasonable, then I do agree with you. The question is, why are we having these in many countries these stupidly small, like mostly caps in mobile network? Is it because we create artificial underload in the mobile to be able to operate without quality of service? Or is it just a pricing trick? That's a good question.
So if we're going to start talking about pricing and costs and capacity, Brian Trammell, if you can go back to the big colorful bunch of boxes slide. No wait, actually go back to one slide before, because this shows the interactions. So that trust and policy controller is going to need a key for basically everything that has a capability associated with it.
In this particular idea, yes.
For the amount of money that it's going to take me to build and operate that PKI, how many 10 gig links can I get? And how many more radios can I put on the tower? I'm guessing it's more than one. PKIs are not cheap. Right? I mean, not even the engineering effort of trying to build this. I mean, this is a box and line diagram, and I'm not going to actually go into how you build the box and line diagram. But this trust and policy controller is going to need to basically make, I mean, even just the I've got all of these roles and I'm trying to express the policies to it. Even just that part is an enormous amount of management overhead.
Yes.
And then building the PKI in order to make that work and getting all of the keys to all of the devices is an enormous amount of overhead. I'm trying to see where the win is.
But I think I get part of your point. I might not get part of your point. Sorry for that. But
so I have 2 points. One is, once you build this, there's so many other really evil things you can do with it that I don't want anybody to think that this is a good idea. And two, I don't think that it is an economic. I mean, I'm happy, but that I don't think it is an economically viable idea.
But then I have a counter question. How much did it take to develop AdBlock Plus for the browsers?
How much did it take to develop AdBlock Plus for the browsers?
And did it help the users in a way decision, or did it hurt the user's decision?
I'm not sure what I don't understand the question.
Okay, AdBlock Plus is a
I know what AdBlock Plus is.
But that wasn't developed by the operators. It don't have to be necessarily developed by the operators, this trust and policy.
Well, somebody has to develop it.
Yeah.
Who's going to develop it?
That's a very good question. Someone who would like to get the advantages of, for example, middle-box cooperation, for example, selecting transport protocols, but at the same time would like to have control. And that should, I think it could be a community development. And what I envision is a community development, not an evil corporation development for this one. And especially the data, even if this is developed by the corporation, I think it should be possible to replace the database to a database controlled completely by communities.
So I just want to say that we closed the lines after Matt. Oh.
We'll take this offline because I can't see it. Thanks.
Okay.
Matt Mathis. So one of the things that is influencing design of the internet today is that there is the trajectories for the cost of memory and the cost of bandwidth are actually have substantially different slopes. And the problem is that memory has to beat Moore's law squared in order to keep up with the links. The reason is because as the links get faster, you both need to make the memory faster and you need to make the memory bigger. And you see this in things like even simple high-speed switches. The queuing time is going down because you can't afford the memory to make the queuing time anywhere near the delay bandwidth product. The state for running this kind of protocol in the middle of the network blows up compared to the cost of the bandwidth. You're essentially on the wrong side of the migration. What we're seeing today in the internet is at the edges you can do fancy things like red and all that kind of stuff. The core is doing drop tail on a 20 millisecond queue or something, or smaller, and those queues are getting smaller as the switches get faster because you can't afford the memory.
I completely agree with your statement. My vision there is that there are boxes, policy controllers, for example, in cellular architecture, which do look at the traffic.
They're relatively close to the edge. They're relatively close to the edge.
Yeah, and they should, in a way, apply existing quality of service techniques in both directions based on this. But it's definitely not something to be terminated in high-speed switches, and it's not something to be terminated in most switches or routers or whatever.
Okay, thank you very much.
Thank you.
So before we close the session a few minutes early, that's just a friendly reminder for people to think about if they would be willing to stand as a transport area director nominee in the coming selection process. And you have a comment, Lars? Or?
Yeah, Lars, I actually have a bunch of people that are academics in the transport area came to me over the years and also now and said, I would consider doing it, but I need support. You know, my university isn't supporting this, or I don't have a project that supports it at the moment. And so if you're at a company, and I'm looking into this for NetApp, right? But if you are at another company, please look if you can fund the university professor, even part-time, right? If a bunch of us get together and pool money, if we can make it possible for them to run, that would be good for everybody. So I'm happy to be the contact point for anybody with money, and I will, you will be the contact point too, because you are stepping down and. Right, yeah.
It would be an offer from our side, let's say, if people are afraid to talk with Lars because they're a competitor or whatever, you're free to talk with Lars, but we as transport ADs can also offer to be like the clearing point where you can come to and say, like, by the way, we would be able to offer money.
Yeah, and it doesn't need to be the full thing, right? I don't know about the full-time. Right. It depends what it costs, right? But it can be a fraction of that if multiple do it.
Right. So just to bring back up something we talked about previously in Dallas, we spent an hour on Friday on the last session in Dallas on Friday, talking about what it was possible for us to do to make things easier for people to be transport area directors. We ended up with, I guess, 5 sets of suggestions that came out of that for the group. I tried to start a conversation about this on the TSV area mailing list, kind of sending out a summary of that discussion from the minutes. And I have gotten some input, and actually one of the things was I went into the session on Dallas kind of, and I think other people did as well, kind of thinking, well, if you had companies that were supporting an area director, that would be a point of conflict, and that what I'm getting as a result of us having this conversation is that does not seem to be as big a concern for people as I thought it would be. So I thank people for the interaction that we've had so far, because it's been clarifying for me and for Martin, and I think for the rest of the area. Having said that, that's really a conversation that we need to continue to have really seriously within the transport area. We, the IASG, said that we were going to try to do some process experiments that we'd be announcing about this time frame to try and try to arrange things so that the time requirement for transport area directors would be less, and actually area directors in general would be less, and we really haven't come up with any experiments. So I'm thinking that the more work we can do within the transport area to arrange things for transport area directors, for us to increase the number of people who are willing to be considered as nominees, I think the better. It may turn out that there comes out a great set of plans from the ISG that solve all our problems, and that will be awesome. But that hasn't happened yet. And meanwhile, Harold, I think, said he's sending out the call for nominations next month. So please keep that conversation going on the TSV area mailing list, because it really matters to the transport area.
Matt Mathis, Google. So I tried to have this conversation inside of Google a couple of years ago, and it went wrong in two ways, one of which is easily fixed. The word support is actually a euphemism if it doesn't contain the word financial, and that actually got misunderstood. It required some iteration, and that caused the second thing, which is a perception of conflict. We've been bringing, Google in particular has been bringing a lot of business before this area directorate, and people said we can't risk there being problems from that. And the fix to that is probably doing something at, I'll say ISOC level, although that may not be the right answer, but at some broader level where the money is blended from multiple sources and multiple reasons. So it's not specific, not at all. There's some distance between any policy and the funding sources.
So you made the comment last time, and since then we both haven't been active, so we are talking in the back already, but we don't have anything we can tell you. So it's just like...
Yeah, plus one to what Matt said. Aaron Falk. When the network came up, there was nothing on the Jabber room for a long time. But then there was one comment, and I kind of missed it. So rolling back to the discussion, the last presenter that we had, there's a question about where this discussion is going to continue.
So the idea is, if this is like the general transport protocol evolution discussion, that should take place on transport area. If it's a discussion about, for instance, offered services, that should go for TAPS, for instance. But if it's like general, how do we evolve transport protocols? What are the requirements? What are the mistakes we have seen in the past or things we haven't fixed? That should happen on transport area so far.
Brian, does that make sense to you? Yeah. Okay, so Aaron Falk, I have a comment of my own about the area director thing. I just want to point out to those people, in particular, if there's any academics in the room or listening, that this whole Stack Evo thing is actually going to bring a lot of interesting work into the IETF. It already has, and I think it'd be kind of an interesting time to be an area director and be in a position to help guide that work through and help make it successful. I think there are lots of examples in the IETF where the area director has played an important role in making work be coherent and working groups be focused on the right stuff and not overlapping and current, et cetera, et cetera. So I would encourage folks that if you have a research interest or an architectural interest, that this is actually kind of a good time to be a transport AD.
That's a very excellent point. I know that many people in this room know this better than I do, but just the idea that, transport protocols were kind of the land that time forgot as far as us being able to get anything deployed for a while. And that, that just isn't true anymore. We're working through that now, where that was kind of a stalling point for a bunch of years. So I agree very much with Aaron. This is a great time to be in transport.
All right. So if anybody is here in the room who hasn't signed the blue sheet yet, you can still come up front and sign it. And otherwise, I think we are spot on. It's 9 minutes past 7, and time for the bits and bytes. Thank you for being here, and see you next time.
And we should mention that we will be at Bits and Bytes if anybody wants to chat with us about being an area director.
Oh, yes. Yeah, sign the blue sheet and you become an area director. Okay. Yes.